Okay, just like I said that the fractions are probably going to be the hardest thing you guys will do this year. I think ratios will probably be one of the easiest things you're going to do this year. To start off with, I kind of want to go over what a ratio is, and so we'll look at what the actual vocabulary term is for that. A ratio is a comparison of two quantities. We see ratios all the time around us. We just don't realize them. And as we start looking at what they look like and how we say them and how we write them, I think you're going to find out that, yeah, you do see them quite a bit. But when I hear the word comparison, I think about you're comparing who's better than, who's worse than. We think about in math, we compare things by saying greater than or less than or equal to. Well, it really doesn't matter in a ratio what's more or what's less. We don't care about that part. So I think an actual better definition for a ratio is probably not a comparison of two quantities, but actually a relationship between two quantities. Telling me how one quantity or one amount is compared to another, or how it relates to another. So I think that the relationship between two quantities is probably the better way to word that. So let's see what it looks like. So as I go about this, how do I write one? Well, there's a couple different ways. We're going to focus mainly on three ways. The first way that we can write a ratio is to write a fraction. Okay, it looks just like the fractions we've been dealing with. A numerator over a denominator, use that same fraction bar. It means a little bit different thing when you have it as a ratio as opposed to a fraction, but it still looks the same. The second way we can write it is using what we call a colon, or you might be more familiar with those two dots, like what you see between the hour and the minutes on a digital clock, or the dots you use to start your smiley face for your emoji or whatever. And then the third and final way is just simply writing with words. And I'll show you, and we'll go over all three different examples of how to write those here shortly. The second cool thing about ratios is that they can represent a couple different things. Ratios can be a part-to-part comparison or a part-to-whole comparison. And so what I mean by that is part-to-part. Are you comparing two different things? Or part-to-whole, are you comparing a part of the entire group? And we'll talk about that here as we go on too. But we can write them as part-to-part or part-to-whole. And it's important to know the difference between the two. So what I want to show you guys here how to actually write a ratio using those three different methods. So it says here, write the ratio of red squares to blue squares. Well, the first thing you have to do is you have to count how many red squares there are and how many blue squares there are. So if you count, there's 1, 2, 3, 4 of the red squares. I'm just going to keep track right here. And there are 1, 2, 3 of the blue squares. Now with ratios, order is important. Notice, it says the ratio of red squares to blue squares. You have to keep it in that order when you write it. So as a fraction, to write that ratio, it would look like this. The ratio of red squares to blue squares as a fraction looks like this. 4 over 3, or 4 to 3. That's how that would be read, or that's how it would be written. Okay, so that's how you'd make it as a fraction. Using the colon, it would look like this. You'd write it horizontally. Again, order matters. Whatever it asks for first, the red squares, has to come first. Whatever it asks for second, the blue squares, has to come second. Keep it in order. Just like in a fraction, you can't change around the numerator and denominator. A ratio is no different. You can't just decide which goes first, which goes second on your own. And then lastly, writing it in words. And there's a couple different words you can use here, but we're comparing the red squares to the blue squares, and a lot of times the words that are in the actual question will help us. And in this case, we're comparing red squares to blue squares. So if we're going to use words, we would write it as 4, 2, 3. So those are the three different ways that you can write a ratio using a fraction, using a colon, or using words. It's very, very simple. Essentially, you have to count up what you got, and then make the fraction, the colon, or the words match whatever you got. So let's try a few here, and let's see what we got. So for an example here, we've got a part-to-part ratio. Now what this is saying that we're comparing two different things. We're looking at the relationship between two different things. So for example, boys and girls are not the same thing. Boys are boys, girls are girls. Now, we could say students, and that would be boys and girls. But in this case, we're comparing boys to girls. That makes it a part-to-part ratio. So it asks us to write a ratio of girls to boys. So again, first thing we got to do is count up the number of girls. And I see 1, 2, 3, 4, 5, 6 girls. And then I also need to count up the total of boys. So I see 1, 2, 3. So if there's 6 girls and 3 boys, I need to write my ratio. And let's do it 3 different ways. So let's first write it as a fraction. So the first thing we would do is say girls to boys. There were 6 girls. There are 3 boys. Now, this might be where you'd say, wait a minute, this is an improper fraction. You need to write it as a mixed number. But that's not true. Because if we change it to a mixed number, then no longer are we comparing girls to boys. Because if I change this, it just becomes 2. 6 divided by 3 is 2. So if I said, what's the comparison of girls to boys, and you said 2, that doesn't tell me how many boys there were. That doesn't tell me how many girls there were. We can, however, and we should, simplify ratios. And this is where it kind of gets a little bit confusing of your simplification. But we could take and divide by 3, which would give me a total of 6 divided by 3 is 2, 3 divided by 3 is 1. So what that tells me is that there are 2 girls to every boy. Now check this out. I could show you that by identifying them with colors. So let's underline 2 girls with green and 1 boy with green. So there's 2 girls to 1 boy. Now let's underline 2 girls in red and 1 boy in red. There's another 2 girls to 1 boy. And then lastly, using black, we'll underline another 2 girls to 1 boy. So technically, you could use the fraction 2 to 1. Okay? But we'll use 6 to 3 for right now. You don't have to simplify necessarily when you write it with a colon. So if I was going to write it with a colon, I would say, okay, the ratio of girls to boys would be 6 to 3. Pretty simple there. You could simplify, but you don't have to. Okay? And then lastly, if you're going to write it with words, again, girls to boys, 6 to 3. Pretty simple. So those are the 3 different ways to write the ratio of girls to boys in this. And again, it's part to part because girls and boys aren't the same thing. They're not part of a group. Here's another example. But this is a part to whole ratio. And you'll see why. We want to write the ratios of apples to fruit. So first we need to count the apples. So let's underline the apples in green. 1, 2, 3. So there's 3 apples. Well, it wants me to compare it to fruit. So it wants to know how many apples are there out of all the fruit that's there. Now bananas are fruit, so are apples. So we'd have to take a total. We already know there's 3 apples. So how many pieces of fruit are there? 1, 2, 3, 4, 5, 6, 7, 8. So there's actually 8 pieces of fruit. So to write this as a fraction, we would make it as 3 over 8 as a fraction, which can't be simplified. We could also write it with a colon as 3, the colon, 8. Or then finally, excuse me, we could use words. Now, the words are going to change a little bit. I know that it says apples to fruit up here, but we're comparing a part out of a whole. So there are 3 apples out of 8 pieces of fruit. So again, it's a very simple change of wording, but we'd say 3 out of 8. The difference is whenever you have a part to whole relationship, we'll use the words out of. Whenever it's part to part, we'll use to. So those are 2 examples. There's a part to part and a part to whole ratio. So with this one, I'm not telling you whether it's part to part or part to whole. We're going to first write the ratio that it asks for. Then we're going to go back and decide, is it part to part or part to whole? So we've got our triangles and our circles here. So first we need to write a ratio of circles to triangles. So if it's circles first, let's count the circles. There's 1, 2, 3, 4, 5. There's 6, okay? And then we need to count the triangles. There's 1, 2, 3, 4, 5, 6. Oh, sorry, I missed one of my circles. There's 7 circles. So I know that I have 7 circles and 6 triangles. So I need to write my ratio. As a fraction, that would look like 7 over 6. 7 circles to 6 triangles. Using the colon, it would look like 7, the colon, the number 6. And then lastly, we're comparing circles to triangles. So we're going to say that there are 7 circles to 6 triangles. Now, looking at that, we want to decide, is this a part-to-part or part-to-whole ratio? So take a look. Are all circles triangles? And are all triangles circles? Well, obviously the answer is no. So that tells me that I'm comparing two different things to each other. I'm comparing circles to triangles and triangles to circles. Therefore, this is a part-to-part ratio because they're two separate things. And they're not all together. Like the last one we had where there was types of fruit. Well, apples can be fruit, but circles can't be triangles. So that's a part-to-part ratio. Using the same idea, let's check this one out. Very similar here, but let's check. It says the ratio of triangles to shapes. Okay, so let's count up the triangles first. 1, 2, 3, 4, 5. There's 6 of them. Okay, perfect. Now, we need to count the number of shapes. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 shapes. Because triangles can be circles, or I'm sorry, triangles can be shapes, and circles can be shapes. So the ratio of triangles to shapes, we said if there's 6 triangles to 13 shapes, then it would be 6 over 13, or 6 colon 13. And then since we're comparing triangles to all the shapes, we would say that 6 out of 13 are triangles. Now, maybe by the wording you've kind of picked up on this, or maybe by the fact that we've talked about how circles can be shapes and triangles can be shapes, that you would understand that this is an example of a part-to-whole ratio. This is part-to-whole because you're comparing one part to the entire group or the whole group of shapes there. So it's really easy. A lot of this is just basically making sure, A, you can count, B, you can put them in order, and C, you remember which way to write them using a fraction, using a colon, or using words. So you try one. Here's a picture for you. I want you to write all 3 types of ratios of dogs to cats. And then I want you to tell me what kind of ratio you've written, whether it's part to part or part to whole. So go ahead and pause the video, take some time, write the ratio all 3 ways, write down what kind of ratio it is, whether it's part to part or part to whole, and then hit play to see how you did. Okay, so let's take a look. This is asking for dogs to cats. So let's first start by counting up our dogs. We've got 1, 2, 3, 4, 5, 6. There's 7 dogs. Okay. And then we can also count up our cats. There's 1, 2, 3 cats. Excuse me. So if I was going to write this as a ratio using a fraction, it would be 7 over 3 because there's 7 dogs and 3 cats. If I was going to write using colon, it'd be 7 colon 3. And then lastly, we're going to write it with words. Now, we're comparing dogs to cats. So using words, we would use 7, 2, 3. Now, whether by using the words that we did, or maybe the fact you identify that dogs can't be cats and cats can't be dogs, you realize that this right here is a ratio that is part to part. You're comparing 2 different things to each other. So this is a part-to-part ratio. Okay. So hopefully you had that one. Now, here's another one. Okay. This time I want you to write a ratio of teachers to people in the room. Okay. So take a look around, and the answer is going to be different for each class. So we'll kind of talk about what we would get there. But for the most part, you should have very similar answers from class to class. So we'll go ahead and write the ratio 3 different ways of the teacher to the number of people in the room. And then also name the type of ratio, whether it's part to part or part to whole. So go ahead and hit pause and hit play when you're ready. Okay, so as I said before, it's going to be a little bit different for each class. But for the most part, your ratio should look fairly similar. Now, the ratio of teachers to people in the room. There's 1 teacher. Now, if you're in first hour, there's probably roughly 26 people. If you're in second, I'm sorry, if you're in fourth, fifth hour, there's around 24 of you. If you're in the seventh, eighth, there's about 23 of you. So it's all gonna be the same. I'm gonna use the number. I'm gonna use the number 25 just to make it easy. So if you didn't have 25, it should be whatever number you had. So we'll go from that. So if I'm writing the ratio of teachers to people in the room, and I'm usually just gonna pretend that there's 25. If there's one teacher, then and there's 25 students, that means that there's actually 26 people in the room. Because can the teacher be a person in the room? Well, yeah, absolutely. Can the students be people in the room? Absolutely. So all of them count. Therefore, your number should be 1 over how many people in the room, including the teacher. Your written as a rate or as a colon, it should be 1 to 26, or you might have written down, maybe there's 22 people in the room at the time, whatever. And then lastly, there's one teacher out of the 26 people in the room. Now, hopefully, after hearing some of that vocabulary, think about this. The teacher can be people in the room. The students can be people in the room. That should tell you then that this is obviously a part to whole ratio because you're comparing one part of the room to everybody in the room. So hopefully this makes sense. Hopefully you now know how to write a ratio 3 different ways. You understand that you can write as a fraction, using a colon or using words. You understand that the order matters, that you have to write it in the same order as what it's asking for in the question. And then lastly, hopefully you are able to identify whether a ratio is part to part or part to whole. Okay. So I've got some practice for you guys today of number 1, writing ratios, and also number 2, identifying as part to whole or part to part. So go ahead and give those a shot and have it checked when you're done.